Again, hi everyone. My name is Dmitry Chuyko. We're going to start this day with my talk about small containers leading us through time and space. Please feel free to ask your questions as the session goes. Just unmute yourself and ask anything you want to ask. And so we start. I work at a company named BellSoft. We release our own binary distribution of OpenJDK called Libc. And we had, well, good experience in doing that for years. So in this area, if you noticed, this September, JDK 17 was released. So it's a new LTS release, and we also contributed in that LTS release. So small containers, why do we even talk about containers? It's a funny question because, nowadays, that's probably the preferred way to deploy our real applications because it's so convenient. We reproduce a simple environment and then we tune it from the outside to live our different services and systems together using code as configuration and other good practices. But the basement consists of such concepts as a container. And we can deploy using different schemas. First of all, we can create a container image, a standalone archive, and transfer it in this or another way to some host. And this surprisingly will work. If there is some container system, container management system, we can offer that archive and really create an instance of that image. But that's not probably what we do every day. We most typically use some registry. We use layered images, and registry helps us to deal with caching and all that nice things. And that registry may be some local instance, it may be some service provided by cloud provider or whatever, or some service provider that's specialized for providing us a registry like Docker Hub, for example. And then we transfer that actual container images. We cross some network bounds. Like it all may happen inside our local network. It may go to some third-party registry, and then so we can upload from one developer network, for example, to that registry and then back, or so it can be located differently. And the same is true, then it's provided as a service, and we can also raise a mirror of a registry to reduce traffic or for some other purposes. And all that's not for free. That's the main point. First, we have most probably we have some limits when we use a registry. Either it's SaaS, and there are also some limitations, or if it's if cloud providers gives that for us, it may look free, but it's actually not. Then we use Docker Hub. Free account has now its limitations, and yeah, for cloud providers, we pay for the traffic, especially if it crosses region bounds. If we raise our own mirror registry, then we have to maintain it, and it will cost our resources. So as I said, traffic, machine time, storage, and of course, time of human specialists. Obviously, if we transfer less, it looks better. So smaller containers can help. And let's look how it works. First, which part we will decrease? Well, we'll focus on base image. And in the world of JDKs, base image contains some runtime, but more formally, it is just a parent image, and base image, it is something on top of Scratch. But in any case, I will use both terms. So typical applications can be split to layers, then they are containerized. And of course, there will be some base layers, div Java runtime, some OS packages required to the Java runtime. There are actually two OS packages layers. One is below Java runtime, and one layer which is not a base actually may be required for our application if it uses, for example, some native libraries or some packages and operating system required for its work. Of course, OS part, the OS environment, it's not the actual OS, right? We still have some interesting mechanics of how system calls work in a container, but in any case. And of course, top layers, that may be some libraries, framework, and as a separate set of libraries, and the application itself, which is typically very tiny. On Docker conference, there are two interesting polls. So they're in Russian. I will translate it to you. How do people create their containers? So still around 50% create a Docker file themselves. Some use JIP, quite notable minority. Like 30% still don't use containers. I think that number decreases year to year. And few use cloud native build packs. I think that number increases very dramatically because Spring promotes that ability, and I will cover that slightly in my another talk, and you'll see that there are real benefits. So we talk about optimizing top of our containers. So what we can do? Well, we can split all our production business logic very carefully to keep that tips of pyramids of icebergs very small, so we could easily update that. Because then we update the top layer, we don't touch layers below it. It is really cheap. We only transfer that tiny layer. Then, of course, we can select carefully the set of libraries that we use, maybe more lightweight framework or flavor of the framework. And then we can select between different OS variants. So for same packages, but with different OS layer flavors, we can have different sizes. That also plays a role. Well, still the largest part is the base part of the image. Here we have different criteria for choosing that base layer. That may be size, it may be performance, it may be security updates and their release schedule, all different things. I will focus on size because we started with this problem. Then it's huge. It's just it may become expensive. So what we can do here? We can select smaller cherry. For example, we can take only client VM. That's exotic, but it still makes sense. We can go to native image space. It has its own caveats. I'll talk about that in different talk. And of course, we can go for smaller OS images. Or we can think about having no OS images. So we go to distroless space, but it's not so obvious because there is actually a distro. We just don't have package manager. And well, we can try to base on Scratch for some simple programs, but that's not about Java. We still have to have something. Even for native image, there are some interesting issues. So if we want to know what's the size of the image across the wire, right, then we transfer it. Well, we can enable some diagnostics, in this case in Docker, and we can inspect the image. Let's take some image. There will be clearly visible layers, and that layers, they transferred over the network, altogether take more than 250 megabytes. What's even worse, when we uncompress it, it takes over half of a gigabyte. This latest JDK, that's probably for 11. Sorry. For the latest JDK 17, it's slightly below 500 megabytes. It's like 475 or something. But still, it's huge. And it's better to know what JDK is in there, how it's updated, right? Such a huge container, if we provision it to a clear machine, to clean machine, or the 100 megabytes network, which is rather average. That's my home network, for example, and it takes half of a minute. I can say, I will present one or two slides during. So something that might look free, like using container registry in a public cloud, maybe not free, in fact. We still can pay for storage. We can break some limits. We can cross region boundary and pay for traffic. So it's so easy to lose money here. And if I have not a public cloud deployment, but some private cloud, well, we, for example, our organization may manage it by itself, which is rather expensive in case something unexpected happens. And the network may be not so fast, then your 28 seconds turn into like 5 minutes, which is absolutely not good. So when I talk about OS images with JDK, JDK can be installed there using different ways, using package manager or using binary archives. Anyway, it all must be tested together. So please do care about that. Was it tested for compatibility? What's the update practice? OS-based images are very different, and their size is different tenfolds and even more. And 3 interesting components can be highlighted here. That is a standard C library. Well, why do we need that? Because we have many programs, including HotSpot JVM, that use that library. Package manager, that helps us, and shell. They may be different. And then in this area, one unique distro exists that is even less than so-called distroless. but still contains that free components. It contains standard C library, which is extremely small, contains package manager, and a shell. So that's Alpine Linux. And if we build JDK images on top of that, we get extremely small ones. So you see, even on disk, it's actually smaller than 100 megabytes. And pull time for that image will be pleasantly, it's like a blaze. It's very small, only 4 seconds. So containers do help. They help both for slow network and fast work. But what's inside? Well, Alpine Linux is a special one, not probably the one that you work with daily. And we'll talk about that briefly. What are the differences? It's not that complex. First, as I mentioned, there is a different implementation of standard C library. It mostly tries to use original system calls, so only provide wrappers for that. It follows POSIX standard and few extensions. It's implemented using clearly coding practices like base standard in the code, to write simple code, to use less memory, and so on and so on. And the size is optimized, not losing some important things like UTF-8 support. And again, I will repeat that compatibility, which allows to port such programs as HotSpot. But if we talk about Libc implementations in general, there are different ones. So how we would compare that? There were some comparisons, and as I understand it, musl creators participated actively, and they were involved in doing that comparisons to understand what can be compared, what we should focus on, and what information, what are actual results there. The important outcome of all the tables is that in some cases, in something, glibc is better. In some cases, musl is better. More green ones is good. But to me, important points are compatibility, of course, and everyone asks about performance. So, well, there were no large performance degradations. There are some, of course, known places in glibc that were specially optimized by using some sophisticated code, etc. But that's that are only particular points. Other Libc implementations, as you may notice, have more kind of bread blocks here in this table. Well, that means that probably it would be harder to have containers based on that. Yeah, not the least part is platform support, which is very interesting. We have JVM on many platforms, and it would be good, an option to have musl Libc for as many of the platforms as possible. As I said, why do we need it? Because HotSpot JVM is a C++, C, and assembler program, and of course we need standard C library for that. Another key component of Alpine Linux is PCBox. It's a Swiss Army knife tool that mimics all different Unix command lines. So then you invoke shell, or you invoke ls or cat. It still raises same binary, all compiled in one, and it understands which command is invoked and acts accordingly. Well, it helps it to stay small because of sharing the code, and it's compiled to be small and well effective. It's just slightly different. We can't update tool implementations and separate, but we see that while right. Some things mentioned here, like environment variables, we will look at that later in the examples. So Alpine Linux, again, musl, busybox, also OpenRC, APK package manager, rather simple, but it has all the things that we need. And special care about standard executables and packages. So it's not desktop-oriented. That's why probably why we don't see it often in conferences, but we often see that in containers for different languages, not just for Java. There are some issues sometimes, but they are solvable. And for Java, of course, we cannot just take ready-made binaries and run it on a different on a system with different C library implementations that won't be linked dynamically. So we need a port for that. We need special binaries, and this port has been implemented during JDK 6 timeline, so late last year. The integration was performed. Actually, the implementation existed for like a couple of years, and our company, BellSoft, took responsibility to bring that port from Portola Project into OpenJDK mainline. So as I said, a few years ago, JDK Portola started. There were even some experimental binaries, even from Oracle for Alpine, not provided now, but the history is interesting here. So what's the nature of new port? We need to determine during compilation which library is used for the JDK build, and we need to treat it properly. There are some incompatibilities with glibc because glibc uses more extensions and understands some undefined behaviors differently than musl. You know, in POSIX standard, there are still undefined behaviors, and you should not rely on what really happens inside. And also build environment and instructions and documentations, all about that. Well, in the end, then we got something, and we need, for example, to use musl for JNI build. It's very easy. We can just, in the case when we are in Alpine environment or we don't need that cross build, we just invoke GCC and say, okay, please create native library for us. No problem. And we can run it. Even on Alpine, but in Alpine musl, it may actually not work. And this lucky case it does, but still we'll see the reverse. So let's make a cross build. So we take a cross tool chain mentioned in the instructions for JDK. We can also use it for our JNI binaries. So if in our project we have JNI, we have to port it for Alpine Linux if we want to move to Alpine Linux in our production. That's an important point. So that's why we need that cross tool chain here. So we simply take that and use compiler from cross tool chain. That's it. And we create a binary, and it works in Alpine musl environment. But that won't work, for example, in my local environment on Ubuntu without musl. it will just say, okay, that the elf header is invalid. Please don't try that binary with me. During porting, there were some interesting issues that also may be interesting for application developers, like LD preload. The musl-based systems work differently. So here, Alpine Linux is not unique. For example, on AIX, this behavior is also different from glibc-based systems. Again, thanks, we have so standard POSIX. In all the kernels, some security extension was enabled by default. So if you install Alpine Linux in bare metal, for example, on some embedded device, and if it's old enough and you try to run Java, you won't be able to do that because of JIT compilers, generating code and transferring control to that code. So it's prohibited by default. You can enable it, or you should see some message saying what happens really. So this diagnostics was added. Also, debug problems were successfully resolved, but you have to take probably properly prepared containers to have that working. And if you debug the JVM itself, it looks slightly differently from developer perspective. So, but still, you have to skip a few more things to go to where your debug actually works. So for off-screen rendering, which we still see even on backend applications, you need to install more stuff, like just install free type and necessary fonts, because they are not there by default. That really sounds obvious, but you might face it as a problem. And for native memory tracking, you need, again, the latest Alpine. Not so latest, currently it's like 3.13. But if you take latest ready-made base images with JDK, you have it out of the box. And in a probably rare case, then you run Alpine on NUMA system, you also need to install libnuma for better support of NUMA in JVM. There are some differences in how standard tools behave. Like some flags may be missing. Again, refer to the standard and refer to musl document and busybox documentation. Some requirements by security reasons, by the way, for shell scripts. And there were some issues with serviceability agent on JDK 8, and it was just disabled. So let's look at examples. You can change 15 to 17 here, nothing will change. So if we create a script which says hello, try to invoke hash in the beginning, saying, okay, this is a shell script, please invoke this shell binary for me. So in that case, everything works, just write proper scripts. Environment variables with dots, maybe not so easy to use, like the example here. But the same problem is true for other Linux distributions, and they just behave differently, but don't keep the entire variable name. But fortunately, frameworks help us, like Spring, for example. We just use underscores and everything is mapped to the right names. Serviceability agent in JDK 8, there was a -f option, right? And if you try it on Alpine musl system, so I didn't mention that for 2 example containers here, they are different in the sense that the one having name musl, it doesn't have a glibc compatibility layer. So this compatibility layer adds like 24 megabytes in size, but allows to run any glibc-based programs, including the original port of HotSpot. So as you see in this JDK compiled for musl, there is no -f option for JSTAC, for example, and other service stability agent related tools. But if you take any modern JDK starting from 11, for example, in any case, there won't be that option. So not a big loss. Again, port is an upstream, but what's about native image? Well, then you take that, you can have smaller images, but the layers, top layers won't be thin. I will cover that separately in my other talk. But the goal of using native images is often a super fast startup, not just seconds, but fractions of a second, without sacrificing peak performance. So there are some specific issues. Like, for example, native image is not fully and entirely supported for all the parts of all the frameworks, right? Because from both sides, there are some problems still waiting to be solved. But then you decide to create a container. Native image is always an option. Well, slightly later, look at some diagram showing the choice possibilities. Okay, so Alpine Linux is great, JDK portal, Alpine Linux is great, but people still stay on it. And it's still about 50%. So the number N here is still around 50. Well, that TARDIS also exists in that land. For JDK 11, which is LTS version, we have historically, for Liberica, we have ports starting from JDK 9, I mean Alpine musl ports. And this year, we also released musl port for JDK 8 updates. So if you take any long-term supported version, you will have an option for Alpine musl Linux as a binary or as a container. And for all that variants, there is support for server arms or for embedded. For example, you can flash some of your devices like routers or embedded boards with musl-based distributions like OpenWRT, which used to be based on different C library implementation, but now by default it is musl-based, and you can run that JDK port there. So when we select containers, we may be focused on size, but please remember this scenario that you're in. Like, do you have frequent clean updates of your images, or you have frequent layered updates potentially? That may mean, do you have an elastic fleet in your deployment, or you have kind of defined and static fleet of machines? Because yeah, with native image you have smaller size of a container typically, but for clean deploy, it is much larger than thin layer. Then please see, do you use thin jar or fat jar strategy? How do you slice your container using standard tools? I mean, something that framework provides, or you do it by yourself. What are critical thresholds here, or trade-offs between some developer efforts and actual limitations in the deployment environment. And then we select necessary tools from container environment. Like, what OS requirements do we have? Do we need something special? Like, do we need shell at all? Do we need to run any diagnostics inside a container? Even like if we kill it after that, still we might want to run some diagnostics before. If we don't need all that, maybe we need to distro less by some reasons, like, okay, let's narrow down the attack surface, make it smaller by excluding some components. That may be the point. Or like we say, okay, we need the package manager and shell, but we need some standard ones, like we need full bash compatibility because something's not compatible with other shells. That may happen. Or we need glibc for some reasons, like maybe some package in native packages in Alpine is not up to date enough. That may happen. Or we need glibc compatibility layer for something. We need some other like homegrown native components, which we cannot cross-compile, for example. That's a rare case from my perspective. In many cases, Alpine Linux is great, and we don't need glibc compatibility layer, which will make our base layers as small as possible, and it will help to keep the top of the pyramid also slim. So we have wide range of options. Options to design our containers and build them. And in all that cases, we can try to decrease the size of containers. There are good tools for that. We discussed some of them. Please come to my another talk. We'll talk more about native image options. There is a special Alpine Linux, and JDK is ported to that. Even though there are some interesting peculiarities in the Alpine Linux environment, it's still fully usable, and the JDK is fully tested, and it is supported just like in other environments. And you can right now get smallest containers with Alpine Linux by just providing right pull line in your Docker or Kubernetes. Okay, I'm ready to your questions. And thank you for your attention. Let's check the chat. Okay. Questions in chat so far? Yeah, thank you. Yeah, you can write questions in chat, or you can just ask using voice connection. Can we add locales to Alpine as easy as in Debian-based base images? Yeah, it's pretty much the same. What's interesting, we recently had some changes. If I remember correctly, it was Debian, which made us to slightly change the build process for our Debian-based containers, and that were related to default locales. I hope that other vendors noticed that too. So again, as the container downloads almost instantly, it's very easy to try anything you have a specific concern about. Like, for example, managing locale and running your application with a different one. Because this is a German conference, I believe that you can try German localization for something. Yeah. Thank you. What do you think about Adoption and why choose BellSoft to build their own images? Oh, that's a great question. We are preparing material about Timorin and Liberica. So basically, it's very interesting and major player in the area of different OpenJDK distributions. But as you mentioned, that's Adoptium is an Eclipse Foundation project, and it has its own direction. I know like few points where we definitely do it better. So please wait a bit for that material. I think that would be explained in more detail. Then created an image deal with BuildX for the Raspberry Pi Pico platform. The suggestion is still Alpine musl. Yeah, great. I don't know if I think JDK will run on Pico. In that sense, that would be interesting to try. So we tried at least Pi 2 for running Java, but maybe Pico is also suitable platform. Please write us if it really works. What are your impressions if you run it on Pico? The Alpine image. Yeah, that sounds interesting. Okay, do we have any more questions? Can you tell us about the certificate that expired on September 30th? Which exactly certificate do you mean? Let's encrypt. Well, as far as I know, there are no kind of dependencies on that. So if you just take all the recent stuff, it will just work. If you had old enough application, at least for native applications, that's true. If you have certificates embedded, and you won't be able to connect to some external resources. Well, again, one more reason to update your JDK. Not sure if even the really old versions of JDK are affected here, but for new versions, we definitely update some certificates embedded. Okay, do we expect it to proceed in some external breakout room, or? Yeah, thank you.